I just reviewed a client's AWS bill where they were paying for 3 separate transit gateways across their organization because nobody understood route table association and propagation. That's $1,500 a month in wasted infrastructure, and their network was actually less secure than a single properly configured transit gateway would be.
Okay, that's painful. I've been trying to wrap my head around transit gateway route tables, and honestly, the difference between association and propagation still confuses me.
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm your Network Ninja, and with me today is Cloud Cadet learning the ropes of multi-account networking.
Hey everyone! Today we're finally tackling the thing that's been haunting my AWS console.
We're going deep on transit gateway route table association versus propagation, and specifically how to use them for proper network segmentation across multiple AWS accounts.
So here's my problem. We have a transit gateway connecting our dev, staging, and production VPCs across 3 different AWS accounts. Right now, everything can talk to everything, and our security team is not happy about it.
Classic scenario, and it's exactly what route table association and propagation solve. Here's the thing most people miss. A transit gateway attachment and a transit gateway route table are 2 completely different things, and the relationship between them is where the magic happens.
Okay, break that down for me. What's an attachment versus a route table?
Think of your transit gateway as a massive airport terminal. Each VPC attachment is like a gate where planes arrive and depart. The route table is the air traffic control system that decides which planes can go to which gates. Now here's the critical part. Association determines which air traffic control system a gate listens to, while propagation determines which gates advertise their existence to which control systems.
Wait, so association is about receiving routing decisions, and propagation is about advertising routes?
Exactly right. When you associate a VPC attachment with a route table, you're saying all traffic leaving this VPC through the transit gateway will use this route table to decide where to go. When you enable propagation from an attachment to a route table, you're saying this VPC's CIDR blocks should automatically appear as destinations in this route table.
So if I have my production VPC associated with a production route table, traffic leaving production uses that table. But I also need to propagate production's routes to other tables if I want anyone to reach production?
Now you're getting it. Let's make this concrete. Say your production VPC is 10.1.0.0 out of 16, dev is 10.2.0.0 out of 16, and shared services like your Active Directory and monitoring is 10.3.0.0 out of 16. For proper segmentation, you'd create 3 route tables: production RT, dev RT, and shared services RT.
And then I associate each VPC attachment with its matching route table?
Yes, but here's where it gets interesting. You associate production VPC attachment with production RT, then you propagate shared services routes into production RT, but you do not propagate dev routes into production RT. This means production can reach shared services but has no route to dev. Traffic literally cannot flow because there's no route entry.
Oh, that's elegant. It's not a firewall rule that could be misconfigured, it's the absence of a route. The traffic has nowhere to go.
Exactly, and this is defense in depth. You should still use security groups and NACLs, but the route table provides network layer isolation. Now, for shared services, you'd propagate both production and dev routes into shared services RT, so shared services can respond to both environments.
What about the dev route table? I'm guessing we propagate shared services into it, but not production?
Correct. Dev RT gets shared services propagation only. Now here's a pro tip for multi-account setups. When you share a transit gateway using AWS Resource Access Manager, the attachments from other accounts still need explicit route table associations. The default behavior is to associate with the default route table, which is usually not what you want for segmentation.
So when another account attaches their VPC to our shared transit gateway, we need to manually associate it with the correct route table?
Yes, and this is where I see the biggest mistakes. People share the transit gateway, accept the attachment, and forget to change the route table association from the default. Suddenly their carefully planned segmentation has a hole because the new VPC is using the default route table that might have routes to everything.
That's terrifying. Is there a way to automate this?
Absolutely. You can use AWS organizations with service control policies to require specific tags on attachments, then use Lambda triggered by Event Bridge to automatically associate attachments with the correct route table based on those tags. The event you're looking for is Create Transit Gateway VPC Attachment in CloudTrail.
One thing I'm still unclear on. If I have a static route and a propagated route to the same destination, which one wins?
Great question. Static routes always take precedence over propagated routes. The transit gateway uses most specific prefix first, then static over propagated for equal prefixes. So if you propagate 10.1.0.0 out of 16 but add a static route for 10.1.0.0 out of 16 pointing to a black hole, the static black hole wins. This is actually useful for emergency isolation.
So I could have a runbook that adds a black hole static route to instantly isolate a compromised VPC?
Exactly. You can add that static route in seconds through the console or CLI, and it immediately overrides the propagated route. Traffic to that VPC just disappears, much faster than modifying security groups across hundreds of instances.
Let me make sure I've got this. Association controls outbound routing decisions for a VPC attachment. Propagation advertises a VPC's CIDR into route tables. For segmentation, I create separate route tables per environment and carefully control which routes propagate where. And static routes override propagated routes for emergency scenarios.
Perfect summary. One final tip. Always document your route table design in a matrix showing which attachments associate with which tables and which propagations exist. When you're troubleshooting connectivity at 2 a.m., that diagram is worth its weight in gold.
This actually makes Transit Gateway feel manageable instead of terrifying.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with your platform team who's probably struggling with the same multi-account networking challenges.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.